Hi, everyone. Thanks for joining us today. I'm going to go ahead and just get us started so that we can get started on what you all came here for today. I'm Chloe. I'm with the Tri-County Regional Energy Network, and today we're joined by Judy Rachel for a really exciting new training. It's not something that 331 has offered before, so we're really excited to hear all of your thoughts on this using Wrightsoft for residential load calculations. Judy's really going to be walking through how to use this software with you guys. So yeah, it's something different than what we've offered before. We're going to be having a poll for you guys at the end of the training for you to give us your feedback. So we'd really appreciate it, especially for this training, if you guys could let us know what you think of this sort of a training. Right. We can go to the next slide, Judy. Great, thank you. Before we begin, just a few quick reminders. If you are looking to get any learning units for this, we're offering AIA and ICC learning units today. You must attend at least 80% of the training. So make sure that you are attending for at least that much if you are looking to get these units. If you have any questions, you can use our chat or you can raise your hand. And we are going to be recording this session, and you will be getting a copy of the slides emailed to you, and the recording will be posted to our on-demand page, usually within about a month. You can keep going. Okay, and then quickly, just a little bit about who we are. If you guys have tuned into our presentations before, you've heard this, but if you're new, let me introduce you to 3C Ren. We are a collaboration between the Tri-Counties, and our programs reduce energy use for a more sustainable, equitable, and economically vibrant Central Coast. And we receive our funding to do this from the California Public Utility Commission.
What was that?
And then just quickly, lastly, before I pass things off to Judy, we have three different service areas with six programs at 3C Ren. Today's program or today's course falls under our training category and is offered by Building Performance Training. If you're interested in seeing what other events we have coming up, you can go to 3c-ren.org/events. And with that, I'll pass things off to Judy to get us started today.
Great. Thanks. Hi, everyone. I want to get us to kind of set our screens up right, if we can, right now, for what's going to happen later on in the webinar. But if you don't manage to get it set up right now, then please stop playing with it. Pay attention for a little bit while I go through the little bit of PowerPoint presentation that I have, and you can direct message Chloe for her to kind of help you out. And then when I flip over to actually working in Wrightsoft, at that point we can futz a little bit more with people who haven't quite gotten into the full view that I want you to get into. And so what I want you to try to get into is into full screen. And on in my Zoom, what happened was is that I went to full screen, and then when I went back up to view again, which is going to be up in the upper right hand corner of your screen, I could click on full screen a second time. And what that did for me is that it unlocked. So you should see that I moved to show up. No, it's on top. You can just see my cursor. Okay. What it did is it unlocked my the little video view of me from the rest of the screen, which means that you can move it out of the way if it's getting in your way during the rest of the presentation. So that was the first thing, is trying to unlock the little video picture of me and giving you the ability to minimize it to different degrees. Then the second thing that I would like you to do is to find where you have your different view options that are slightly different than this dialog box on the side here. There should be another view options, which gives you things like choose fit screen. And that's the one that is going to work best for working in the live software that we're going to be working in. And then there's certain windows in that software that I'm just not going to be able to blow up on my screen. And so when we get to those, if you know where your little view option is, and mostly, I think if you hover across the top and bring down a little toolbar, you should be able to find it there possibly. Um, you can also go into either 100% or 150%, which will blow the little screens up so you can view them better. And then when I move away from those screens, you can just flip right back to choose fit screen to continue following. So you're going to have to be a little bit involved in order for you to get the best viewing pleasure of this webinar. So hopefully some of you have gotten that figured out, and we're going to start. So, what I want this webinar today to be is that I want to teach you load calculation procedures. Um, the softwares are not teaching you the procedures, and the softwares are based on the procedures, but they're not teaching you the actual manual J procedure. Uh, and for those of you who do have your video screens up, Manual J is actually a manual. It is truly a very thick manual that gives us the procedures for us to do an accurate load calculation estimate. And so we really need softwares to do the complicated math. And Wrightsoft is the software that I've been using since I began doing load calculations. So that's the one that I have available to work with to teach you the actual load calculation procedures so that you're filling in the right things in the software and you understand how to get those numbers and where to get them from. So we're not going to be able to cover every single aspect of Manual J, and we're not going to be able to cover every single aspect of the Wrightsuite software. And we're absolutely not going to be covering system selection. That's Manual S. It's not Manual J, and we're talking about Manual J today. We're not going to be doing Manual D or duct design or any other system design. We're not going to be doing air distribution. So this is only about the Manual J procedures today. So what is a load calculation? Well, the actual definition of a load calculation is that it's the measure of the energy needed for the heating or cooling system, however much they need to add or remove from the space in order to provide the desired level of comfort. So we've got all these various climates throughout the world. And in some climates, we could be potentially comfortable all day and all night without any space conditioning and without anything potentially more than a grass hut or a tent. But we've got all kinds of places where it's perfectly pleasant during the day, but then the nighttime temperatures happen or different seasons happen. We also have different climates where literally you basically cannot go outside at pretty much any time of the year without wearing, parka and full winter gear. And then we've got once again, places with seasons or places where it's only cold at night. So we've got, all these different climates with all of these different temperature ranges that are going on. And so we have built environmental separators. We have built buildings, our homes, that truly what their main purpose is to separate us from the outside environment. So the load calculation is the calculation needed to help us figure out, well, how much conditioning that do we need to do in this environmental separator that we have created so that we can survive fairly comfortably, at least, from the outside climate that is potentially inhospitable to us. The entire goal of the load calculation procedure is to give us the numbers that we need to use in order to size heating and cooling equipment. This right here on the right side is the load meter from the Wrightsoft software. And so after you've completed a load calculation, this is one of the places where you will see the heating and the cooling loads for the building. And then these numbers are used to then figure out, well, what capacity system will meet these loads, and therefore that's what size equipment I should be choosing. So that's the entire goal of the load calculation procedure, is actually to enable us to choose equipment, the appropriately sized equipment. ACCA Manual J. It is the ANSI recognized standard. ACCA went to all of the trouble basically to not only write a very full procedure, but to then write it in a standardized form that ANSI, combed over and said, all right, we recognize this as a national standard that absolutely can be used for this load calculation procedure, and that's going to work. So ACCA Manual J is actually the only load calculation procedure that is ANSI recognized. It's really the only kind of complete procedure that really walks us through managing to get a load calculation done. Um, ASHRAE has an amazing book, their book of fundamentals, which explains the entire process and everything that's going on and explains you how to figure out the math. But they don't actually give us a procedure to go through to get us to the heating and cooling load calculation in any way that we could possibly, that our brains could possibly wrap around, most of us, and that we could get people to pay for. So ACCA Manual J has really become the thing that we use to do load calculations. Understand that Manual J, when we talk about Manual J, it's the residential load calculation. There are load calculations for commercial buildings. There are different load calculation procedures depending upon the use of the building and the type of the building. So Manual J is good for single family detached homes, small multi-unit structures, condominiums, townhouses, and manufactured homes. This is the basic categories that Manual J is the appropriate procedure to follow. It is not to be used for earth berm or earth covered dwellings. It's just not the right procedure to figure out the heat transfer through those buildings. It's not appropriate for homes that have passive solar features. And then any really unconventional construction techniques like straw bale, rammed earth. The earth ships are built with bottles and cans in their walls. And those unconventional construction techniques don't lend themselves to the heat transfer equations that are being used in ACCA Manual J. It's also not to be used if even if it's a residential building, if there's any type of commercial activity that's being conducted in the space, then Manual J is not the appropriate procedure for that. And then spaces that contain swimming pools or spas, those actually need their own very special load calculation procedures as well. So heat transfer through buildings is really quite complicated. And the uh, Manual J even states that the load calculation is actually a gross simplification of the physics and the math that's necessary to determine the amount of energy needed in a space to provide comfort. So it's just that houses are complicated, heat transfer is complicated, and uh, even with this fairly complicated procedure, we're still coming up with an estimate because the physics and math are just so complicated. And so what that means to me is that for all the things that I can absolutely measure and get completely accurate. So I know what the measurements are. I know what my blower door test number is. I know what, I measured the house carefully. I got my NFRC values from the windows. All of those things are going to help me create a more accurate estimate than if I'm sloppy about those things or if I don't take the time to actually do things like a blower door test. So let's talk about the various softwares for just a second, because this isn't about me trying to sell you on using Wrightsoft Universal. Uh, Within the load calculation manual itself, there is actually all kinds of guidance to software developers on how to translate this into software. And one of the main reasons being is that except for the most simple of houses, the calculations really have to be done by a computer. And so we really need softwares to help us out. So there's all the guidance on how to create the softwares, and then the softwares then need to submit to ACCA, and ACCA goes through to figure out whether they feel that what the output of those softwares, if it actually is giving answers that are following the ACCA procedures. So you really want to look for softwares that have this logo. They're allowed to display this logo, powered by ACCA Manual J. And that means that overall, the software has been approved by ACCA that it will come up with uh, accurate estimates if you use if you use the software correctly. So when it's not used correctly, you're going to end up with an inaccurate and a misleading answer. And of course, anybody who's not studied Manual J is going to have no idea whether, whether that's right or not. And so understand that software is a very powerful tool and it's a very useful tool, but it's not magic and it's not the procedures. It is just a way for us to put the procedures into the software for the software to do the math for us. And so ACCA says that the Powered by Manual J logo, use uh, demonstrates reasonable compatibility with the standard, but ACCA still doesn't certify or warranty that the products are going to be free of emissions and errors or that the products don't use data procedures that are not in the standard. It's really our responsibility to understand the procedures. I want to show you what the other softwares are. There's Elite, there's AdTech. Energy Gauge is Florida Solar Energy Center's load calculation procedure that is ACCA approved. And you all might have heard of Quick Model, which is a fairly new software that's out there. And I know 3C Run has run some webinars around Quick Model. Quick Model actually uses Energy Gauge as the calculation procedures behind them. And then there's ones for the iPad, Caramel Soft, and then HeatCAD. A bunch of them you'll notice are Windows platform. CoolCalc, Amply, Zero Homes, and then Conduit Tech. Those are currently the only softwares that have the Powered by Manual J logo approval. So the data collection, the site survey, Manual J states that you have to be honest and aggressive in terms of collecting your data. It's an engineering tool. It has what they say is an inherent and appropriate factor of safety. And any attempt to add other safety factors or to manipulate the procedure may result in unacceptable performance, and especially at what are called part load conditions. So, not at our design conditions, not at those really hot or cold days, but throughout the whole year as we're needing conditioning. Uh, it it just makes the comfort in the homes less and less acceptable when we're not honest and aggressive with our site survey and our inputs following the procedures. And then the consequences of not making a detailed and accurate load estimate are that the errors, whether those are accidental or whether they're intentional, they filter through the entire design process. So starting from choosing your piece of equipment, you're going to choose the wrong equipment capacity. You're going to design your ducts for all the wrong airflows and at the wrong sizes. And then your grills are going to be designed wrong because they should be set for a particular amount of air. So it filters through the entire design process, causing the entire thing to miss the mark. I want to take a moment to talk about that inherent safety factor. There's a rumor out there in just the general world that there are safety factors in the load calculation procedure. And so the load calculation procedure, as I just quoted, states that there's this inherent and appropriate safety factor. It's not that safety factors are actually added into the procedure. It's the fact that the mathematical equations are not in all whole numbers. There's lots and lots of decimals in many of the calculations. So even if we think about the sensible heat formula has a constant in it, which is the specific heat carrying capacity of air. And what the load calculation procedure does is it rounds. It's rounding all those decimals up and it rounds it to the first decimal point. So, whereas when I typically do the sensible heat formula, I would use 1.08 as the constant in my formula. Whereas throughout the entire ACA math and load the manual J math, they're using 1.1. So, right there, there's this little bit of a safety factor for all the hundreds of times that that formula ends up being performed within the calculations. So it's in that way that you're never ever going to come up with an undersized load when you do the procedures properly and you're honest and aggressive about your inputs because all of those formulas are always rounding a bit. And even in the way that we're allowed to measure our buildings, there's a little bit of a rounding up because we're allowed to round the measurements of, say, a wall to the nearest foot. So those are the types of things that end up giving the load calculation this inherent and appropriate safety factor. The site survey is really the most important part. And site survey refers to both existing buildings and plan sets, new construction. So you're either scouring through a plan set to do your site survey, or you hopefully are actually going out to the building and doing that site survey yourself, or having somebody who you trust go out there and do the entire site survey so that you're gathering all the appropriate data. And of course, the accuracy of the load estimating procedure is only going to be as good as the inputs, and the inputs are only going to be as good as the survey. So the types of things that we need to collect in the survey are in general categories. We need to know what the local weather is. So we need to figure out what the design conditions are, the architectural features of the dwelling, all of them, the materials and the techniques that are used to build the structure, and then the types of appliances, because those actually add some internal gains to the building, and the number of full-time occupants. But we need to be really careful about the subjectivity of the appliances and how much they actually add to the load of the building, as well as how much the occupants add to the load of the building. And I'll talk about that more later. The specific types of heating loads are these are the things that during a site survey, so whether scouring the plan set or being in a building, we need to figure out. We need to figure out what the ceiling load is. And we need to figure out, well, is it the ceiling load or really is the ceiling load at the roof deck? So we need to figure that out. And we need to figure out all the layers of either one of those boundaries. There's going to be a wall load. And so we need to figure out how is that wall built all the way from the cladding to the interior. How is that built? There's going to be a fenestration load. So that's our doors and our windows. And skylights and any of those daylighting solar tubes and things like that. And then there's going to be a floor load, and there's potentially going to be different floor loads, just like there's potentially going to be different wall loads and different ceiling assemblies. And then there's the infiltration load, the leakage of the entire building. Those are the heating loads that we need to figure out so that we can put them into our load calculation. Then there's the cooling loads. So the cooling loads are all of those heating loads, but then we also have the internal gains, which are the occupants and the appliances. Now, what we need to figure out for those occupant and appliance loads are, first of all, how many permanent occupants, full-time occupants are going to be living in the house, and Then secondly, what the various appliances are that might be um, contributing to the heat to the load that the cooling equipment is going to need to remove from the house at a late afternoon or early evening on a hot summer design day. So that's like July at maybe 5 p.m. So say there's two adults and three kids. Are the kids really all going to be home at 5 o'clock on a beautiful sunny July day? Are both parents going to be home on a beautiful sunny hot design day in July? Is mom or dad or whoever's doing the cooking, are they going to decide that that's when they should put a turkey in the oven to roast for 5 hours? So that's, so we need to think about what it is that we are putting those loads in for. And therefore anybody who is home, what rooms are we going to be putting those loads in for? There's also some other loads. There are what's called overall system loads. So we need to know a number of things about ducts when they're in the unconditioned space. We need to know about mechanical engineered ventilation. So that's continuous ventilation. So this is not intermittent ventilation. This isn't the bath fan that can just be turned on and off. It is the bath fan that if it's set for continuous operation, then it is that bath fan. It's definitely not the kitchen exhaust hood, right? This is for the continuous mechanical whole house ventilation. Blower motor heat is something that you actually basically complete your entire load calculation. And then when you are looking at the equipment, you need to see if the equipment capacities that you're looking at include blower motor heat or not. So there's a little bit of a iterative process that goes on as you're looking at your pieces of equipment, because if the performance data that you're looking at for that piece of equipment is not including blower motor heat, then you actually need to research the blower motor heat, add that to the load calculation, and then look again to see if the loads still match that piece of equipment that you were looking at. And then hot water pipe in unheated spaces is it's for like radiant systems that might be included in a house. It's something that I've never had to put into my load calculation, so I haven't had to research it very much. But it's for hot water pipes that are going through unheated spaces. There's an entire list of mandatory do's and mandatory don'ts in the Manual J. And so I wanted to just pull out just a few of them for things that I think people think don't matter very much and tend to want to ignore. And being that they're in the mandatory list, that's telling you these do matter. These actually do matter for the load. And some of these are things that in particular are the things that I can measure and be correct about, which helps me know that I'm getting to a really good, accurate estimate of the loads. So some of them are things like taking credit for overhangs. And I think we have some Title 24 people out there. I'm going to say that a number of the Title 24 documents that I have scoured through often ignore overhangs. So Title 24 is very different from what we're doing for figuring out a load calculation. They're for two completely different purposes, and it might be very appropriate that things like overhangs get ignored in that energy modeling. It's not appropriate in your Manual J load calculation procedure. It's not appropriate to not take credit for overhangs. So we need to measure all those overhangs. We need to take credit actually for internal shade devices. So we don't ever make the assumption that people are just going to leave their windows without any type of shading devices. We need to either talk to homeowners and ask them if we are in an existing home, we can actually see them and we need to take note of them. And if we're looking at new construction, we can get a sense of, based on the room and where the type of window, what type of shading device or whether there will be a shading device on that, and we need to make those choices. There is a default that's suggested by the load calculation procedure, and that's to use what's called the medium color blind with slats at 45 degrees. So there is some guidance because there's very few people who don't have some shading devices on most of their windows. We need to take credit for insect screens when we see them installed, when they're specified. Well, we need to also ask homeowners, this operable window doesn't have a screen. Do you intend to leave it that way? And we need to take note of whether those are interior screens or exterior screens, because that actually makes a difference in the load calculation. Take full credit for the rated performance of construction materials, for the insulation and the construction features, and take full credit for tightness of the building enclosure. And the only way to do that is doing a blower door test. And so that's typically easy enough with an existing building, and it's downright impossible with new construction. So with new construction, we need to talk to the contractor and we need to find out, do you have any sense of how tight your buildings typically are? Do you have, is there any goal set up for this building of a tightness number? Is that, is it an ACH? That's fine. I can deal with ACH. I can deal with CFM, but we need to find out how exactly loose or tight, leaky or tight that building is going to be. Now, the blower door test is interesting for the load calculation procedure in that when we typically do a blower door test in terms of, say, an energy audit, we don't tape off the duct system. We include the duct leakage in the total enclosure leakage. But in the load calculation procedures, duct leakage is quantified in a different way in a different place in the procedures. So we need to take it out of the enclosure leakage when we are looking for the infiltration parameters of that house. So we need to first tape off all of the ducts. We need to tape off all the supplies and all the returns so the entire system is not going to show up in our blower door number. So it makes the blower door test a little bit more time consuming to do, but that's the proper way to do it for the load calculation. Don't make worst case, everything is going full blast assumptions about your internal loads. You don't add extra occupancy loads for entertaining groups of people. The load calculation is for permanent full-time occupants of the building. Supplemental conditioning is necessary for those large groups of people. And that's what needs to be told to anybody who is asking you, well, is my home going to be comfortable for all the parties that I love to throw? And the answer is, if you actually want a system based on Manual J and that's going to provide comfort throughout the year and at design conditions, then that's not what we're doing. We're not going to be figuring out how to keep the house comfortable for large groups of people. You're going off the rails, and Manual J is not appropriate for that. Don't add internal loads for special events, same kind of reason. Don't apply safety factors during any stage of the calculation process, and don't apply a safety factor to the final answer or to the equipment selection process. Believe me, you're not going to come up with an undersized load to be sizing your equipment on if you go through the procedures appropriately. All right, so we're going to move on to the live demonstration and what we just reiterating. We're not going to be covering every single screen or input in the software. We're only going to be looking at the ones relevant to doing an accurate load calculation. We're not going to manage to cover all kinds of complicated scenarios. Hopefully, we'll get to a few different scenarios after we get through a simple house. And we're not going to be choosing equipment or sizing ducts. So, for anybody who doesn't have their screen quite set up right, you can maybe communicate with Chloe about that. And I'm going to end that for now. And yeah, so you should be seeing a floor plan on your screen right now. So this is the house that we are going to be doing in for our load calc. It's really a pretty basic house. It has an attached garage, which happens to be where the furnace and water heater platform is. It's got a living room, dining, kitchen, kind of a little hallway. It's just a little two-bedroom house with one bath. In looking at the house, so whether I'm on site or looking at plans, um, I'm going to be looking for, let me see if I can get to that. There we go. I'm going to be looking for what direction the house faces. So on this plan set, there's this nice little note provided that the front of the house is facing 17 degrees south of due west. And so in terms of the load calculation procedures, we get 45 degrees, 90 degrees, so every 45, 90 degrees all the way around. So 17 degrees south of true west means that we would be choosing west for the front of our house. So we need to take note of that. So we set that up properly. Looking at plan sets, you'll typically get a conditioned floor area. And so that is kind of a double check once you've drawn your house to make sure that it is about the same size as what is expected. With something like uh, go, you know, going to a house after measuring it, uh, the county assessor's site is actually the most accurate in all probability. Zillow is sometimes really far off. So I'll definitely check Zillow just to get a sense. And homeowners often have really no good idea of what size of their house is. So they're not a particularly reliable source for figuring out how if you got the size of the house properly. All right. So this is the main screen for your load calculations in Wrightsoft. And where I want us to start is it really helps to be methodical about the way that you go through the load calculations. So I suggest starting at setup, and I suggest basically ignoring those wizards. What I really care about in setup is some of these options and making sure that these options are chosen properly. So the first one is infiltration method. And there are three methods that are described in Manual J. The first two, the simplified method and the detailed method, are wildly inaccurate. The blower door method is nice, it's accurate, and it's not that difficult to do. So I really, really encourage you to buy a blower door, hook up with somebody who has a blower door, get somebody out there who can do the blower door test, and only use the blower door method. The detailed method is literally close to virtually impossible to do. And the simplified method is just a complete wild guess. So try to do blower door. Then under load calculation method, make sure that you're choosing the ACCA Manual J 8th edition. I don't really know why they still have ACCA Manual 7th edition, but I've gotten calls from people before and they're like, I don't know, there's something really wrong with my load calc. I can't figure out what it is. And I'm like, we'll go in and look at your load calculation method, make sure you're using the right method. And somehow it got changed and that's why. So we definitely want those to check those two things. Then we need a decent selection of cities to choose our design conditions from. And so there is this database that comes with this software for choosing cities. Some of the stuff is really pretty old at this point, like ASHRAE 2013. Our design conditions, they change and they get updated. They used to be 30 years of weather data, But now with conditions changing so rapidly, what has happened is that ASHRAE, in particular, is looking at what cities are changing the most rapidly. And if they're seeing a lot of change, then they're actually changing from a 30-year average of temperatures to a 10-year average of temperatures. So I don't really want to have some of these older ones. So I have ASHRAE 2021 checked for my cities. I just have kind of a general ASHRAE because California, Arizona, and Hawaii actually have a lot of microclimates, whereas the other states don't have anywhere near as many microclimates. And so, in choosing just kind of this general ASHRAE, a lot of the microclimates show up that the ASHRAE 2021 might not necessarily have. So, it gives me at least a starting point to build my design conditions for those cities if I can find them in my drop down menu. And then the ACA microclimates, which definitely are a pretty darn full list of all the microclimates, particularly in Arizona, California, and Hawaii with all of our microclimates. So go through, and if you're potentially not finding a city as a starting point, then try to bring on some more cities potentially by clicking some of these other ones. So there's the filter, the databases. Then we'll move on to, yes, I do want above grade volume for infiltration calculations, and I do want adjacent to unconditioned space edges for the exposed perimeter. So I want to see those checked as well. And then since I'm most familiar with the US customary measurement units, that's what I want to see checked. So that's what I would be doing in the setup screen. Then I'm going to move on to show. And so what happens in show is that now I get access to some of the other screens and I can really start getting this load calculation on the road. And so all of this, none of this has anything to do with the load calculation procedure. It's all pretty self-explanatory, what you should fill in. I will just say that this is purely for reports and does not have to actually do with the load calculation procedure. And this number will get filled in by something that we do in another part of the program. This is one of the most important screens in the load calculation procedure and in the software. So I'm not going to be designing the house in DC. My software, and I'm not sure who else, what city other people with Wrightsoft opens up to. My software always opens up in at Washington Reagan Airport in DC. So you're always going to have to go in and choose your weather locations. It's important to choose uh, the correct weather location, and that takes a little bit to figure out the weather location. So what I do is I will start with finding the city that is kind of closest and most representative to where I'm designing and then see how much I have to hone that based on a few other things that I'll show you. So I go up to state province. I'm going to be designing my house today in Ventura, California. So I go up to California, and then I get my list of California cities. And so if I click in here, and I want to look at a few different cities just to show you all just kind of some of the different cities. So we're first going to go down to the O's. So I just clicked in here and then clicked on O, which brought me down to the O's. And so I first want to just look at Oxnard, which is one of our cities in the Tri-County region. And so here we go. With the filter that I put on the weather locations, I have 3 different Oxnard locations basically to choose from. And in larger cities, they actually are different locations within the city. And in smaller cities, they might just be kind of ACA versus ASHRAE. And so unfortunately, design conditions are not set in stone. So we do have to make some decisions. So let's just take a quick look. We get ASHRAE in particular gives us kind of a lot of choices in terms of choosing our conditions. Now, Manual J procedures tell us that we want to choose the 1% condition in cooling and the 99% condition in heating. So those are what we should be looking for and what we should be checking if we're going to start out with one of the ASHRAE locations. So just taking a look, they're saying Oxnard has a design temperature and cooling of 79 degrees, that's dry bulb, and 61 degrees wet bulb. And then in heating, it's 43, it goes down as low as 43 degrees as a design day in heating in the Oxnard area. Now the ACA microclimate is saying 79 and 64 and 41 for heating, so slightly different. And then we've got this Point Magoo at, I think that's the Air Force Base or something. And so then we've got their choices of conditions as well. So then let's take a quick look at San Luis Obispo just to see what you might end up with. So there we go. We've got a couple San Luis Obispo locations, one at the regional airport, and then Santa Barbara. Take a quick look at that. Santa Barbara, we've got the ASHRAE 2021. We have just an ASHRAE. We have an 11W. Now, some of these things you have to figure out what in the world that potentially means. Where in the city is that actually at? Under the 2017 ASHRAE, there's actually two buoys in the middle of the ocean that have weather stations on them that are showing up in the ASHRAE conditions. And so knowing that those are in the middle of the ocean means that they're completely inappropriate for residential load calculations. There's no houses out in the middle of the ocean. So we do need to try to figure out if there's a location that you're going to be choosing that it's not, say, in the middle of the ocean. And now let's go down to Ventura, which is where we'll be using their conditions today as our example. So for Ventura, ASHRAE 2021 and my basic ASHRAE is not even giving me locations or weather data or design conditions at all. So my only choice is this ACA microclimate to get started with. So I'm going to choose that. The bin data actually is not important for your load calculation. So I'm not even going to bother looking at bin data. And if a location says it doesn't have bin data, that's okay because the bin data actually is not important for the load calculation. So I'm going to click OK, and you see that now this weather location stuff got filled in. But take a look and somebody write in the chat, what, if anything, you notice is wrong right off the bat with with these conditions that got put in. So I'll give you a second to type in what you see that might be wrong. And this is something we need to do is, softwares were designed by people and you'll see typos and you'll see mistakes. And those mistakes could end up haunting you in your design. So I see one answer from one person, and so that's something that did not. So Earth Temperature City is in Washington, and that's something that doesn't get changed when I choose a location. But I'll tell you right off the bat that once bin data city and Earth Temperature City actually don't factor into the load calculation at all. So on the one hand, I don't care that that still says Washington, even though it is not correct. But unfortunately, it will show up on some of the reports. So You do want to click on those three dots. You go into California, and there's very few cities that come up for Earth temperature. So you just choose the closest city to the location that you're designing in. So that would be Los Angeles. And that way you can at least get that in. And so this is one of those things that somebody reading a report, whether they kind of know the procedures or not, don't necessarily know that the reports will print things out that have nothing to do with the load calculation itself. So we've got that changed. But there's something else that's actually a very obvious clue that something is wrong with these designs that so far I'm not seeing anybody else has hazarded a guess on. So we'll move on and I'll show you what that is. So there's a few things about choosing our temperatures. So let's take a look. And we've got 80-degree dry bulb, 68-degree wet bulb, and we've got 36-degree dry bulb for heating. So in California, up until January 1st of this upcoming year, our energy code actually was very specific about what design conditions we should use. And on the one hand, I'm going to say that was incredibly helpful because it meant that I could just go to my joint appendices from the California Energy Commission and I could look up a city and I could choose my design conditions. And so all of the differences between ACA and ASHRAE, that basically just all went away with me trying to make a guess as to what I should use because I knew that I was supposed to go to the joint appendices. So we still are going to have joint appendices in the 2025 code that's upcoming. So this is still there, but they've given us a few more choices of where we can choose our design conditions from. So you should check out code and make your choice of where you want to get the design conditions from. I think that for the most part, I've been very successful using the design conditions in the joint appendices, which are based on ASHRAE. So they're based on a very, very solid organization that is, tracking the temperatures throughout the United States. So I feel very confident in what their numbers are. So we've got latitude, elevation, and longitude, which are all important in terms of the load calculation, particularly actually latitude and elevation. Longitude is not quite as important, but it still is important. And we can see that Ventura is at about 34.3, 341 elevation. Elevation is the one thing that I will actually check a home to determine what its actual elevation is because elevation does make a huge it can make a huge difference in the load. It's a substantial difference, and there's correction factors that need to be added that the software knows need to be added when you put in the proper elevation. So I will go to something like what is my elevation? I'll show you that quickly. I'll go to something like what is my elevation, and I'll actually put in the coordinates for the house that I'm designing for and finding out what its actual elevation is, and then putting that in as the elevation for the house that I'm doing. And I can even go as far as to just change the latitude and longitude slightly so it all matches. But this is where, where I'm going to look kind of to see, all right, so, where is this city actually located and about what elevation are we expecting to be designing at? And then they give us way too much information because we're not supposed to use these conditions. We're supposed to use the 1% cooling, dry bulb and wet bulb, which is 80 and 67. And then we're supposed to be grabbing our daily range as well, which is 15, and then our heating design, which they don't even give us actually the 99% condition that we're supposed to use. So, I compromise and it's fully acceptable with any jurisdiction that tells you to use their conditions. is absolutely acceptable by the procedures to use the jurisdiction having authorities guidance. So I take a look at what those conditions are, scribble all of those down for myself, and then go back to my load calculation and I build a city starting with this as my basis. And so this is one of those screens that you'll probably want to go to 100% if you can, if you figured out how to do that in Zoom so you can see it better because I can't make this screen any bigger. So I'm going to go into new and I'm going to create a Ventura location for 3C Wren House. Right? Put in whatever you want. You also have the option of putting in, even a further description for that. Once again, I'm way back in Washington Reagan Airport, so I need to go in and get back to the city that I actually want to be designing for and get that city to fill in. So to get into any of these screens that have these brackets, you need to push function F8, the number 8. And that gets me into that screen so that I can actually edit that screen. So if I want to, between 176 and 341, there's not actually going to be a correction factor that needs to be made, but I could put that in, especially if it was, like 1,000 or 2,000 feet, then we definitely want to make that change. The latitude was a little bit different, and latitude is really important for the solar heat gain. So I do like to be really precise with my latitude. This is what I was hoping you would notice. What's the time zone where we are? It's not -6. So that was a clue to me that, holy heck, you got, Wrightsoft's got this wrong, that the longitude of Ventura is not 9618 because we're not at -6 from Greenwich Mean Time. So I'm definitely going to change that. And I've actually contacted Wrightsoft about this. I want to say 2 years ago or something like that. And they still haven't corrected it. So any of you who are going to be using Wrightsoft and want to use Wrightsoft, I suggest you tell them as well, because maybe they'll change that and we'll get some proper conditions. So I'm changing this just for that report purposes as well. Now, now I've got the elevation, the longitude and latitude correct. And now I need to go into conditions and make sure that the conditions are right. So 80 was the correct dry bulb, but actually the wet bulb is actually 67. So I need to go in and I need to change that wet bulb to 67. And you're going to notice that the relative humidity is going to change because that's just a calculation that the software can do for us, is that when they have the dry bulb and the wet bulb, the relative humidity can be calculated. So that's going to come out correct. And then we need to take a look at the daily range. And the daily range was 15. So we're going to stick with that. And the heating was actually correct as well at 36 degrees. So now I've got all of these conditions. And typically you do want to click the daylight savings. So I'm going to apply all of that and I'm going to select this as my city. And now I have all of these conditions correct, but I need to look at the weather and shielding factor. And this is another thing that we need to look at in our building energy efficiency standards. So we need to go to the current building energy efficiency standards. I pulled up the 2025 one because we're so close to 2025 and find these pages in the building energy efficiency standards, the infiltration, effectiveness, weather, and shielding factor. It's from ASHRAE 62.2. And I want to take a look to see that the weather and shielding factor that Wrightsoft is giving to me is actually correct for the location that I'm designing for. So I'm going through and I'm looking at the various latitudes and longitudes and trying to find what is really the closest and decide whether that is, the same as what the software is showing me or whether I need to change it. And the Oxnard location, the Oxnard airport location is really close to Ventura. And we're showing 0.45. So that's not what the software had. So I want to go in and change that. And this is the screen that I change that in. And once again, it's going to function 8. And now I can change this to 0.45. And I finally have all of my design conditions done. So I can leave this screen, right? That's all that needs to be filled in, but we do need to go through all those various gyrations to get the right conditions. Next, I'm going to go into the zone information screen. The zone information screen is where I'm going to choose the indoor temperature conditions. I just chose the outdoor temperature conditions. Now I need to choose the indoor temperature conditions. And it's going to come up with some default. And you need to either accept the default or change it to what you really want to be designing for. Both Manual J and California want us to design our homes for 68 degrees thermostat set temperature inside for heating and 75 for cooling. Manual J states that we should talk to the homeowners about this and potentially change them a little bit depending on the actual occupants of the house. California is pretty much this is what you're supposed to design at. I can tell you, personally, and having worked with a lot of people, that 68 is really cold for a vast majority of people as a winter design condition. And 75 for a lot of people is a little bit warm. Now, part of it is that their building enclosures aren't any good. So those temperatures don't feel comfortable because of things like stack effect and infiltration and things like that. So if potentially you're getting to do a whole house energy upgrade work scope, a weatherization work scope on a building, then those conditions might end up being more comfortable than anybody would expect based on their current experience in their home that's not a tight home with a good enclosure and good insulation levels. But this is one of those things that you have to kind of make some choices and use some judgment on. But right off the bat, we're definitely not designing in a humid climate in Ventura. So this is actually a climate condition that I created, humid climate. So it's just one of the conditions that of the various ones that I have. I do have Title 24 design conditions, which I can select instead. And so you can make those if you want. So that's 68 and 75. The relative humidity is what's really different from the various climates. Pretty much most climates are we want the indoor relative humidity to be at 30%. That's what we can achieve in our homes, and that's comfortable for our respiratory systems. That's what's part of the comfort zone in terms of the Manual J calculations. In the summer, the indoor relative humidity in a humid climate, it's often difficult for them to get their homes below 55%. And so that's what you design at. If you're in a really dry part of a dry climate, so a really dry part of California or Nevada, Arizona, then the coil on the cooling system, the evaporation coil, may never get wet or very rarely actually get wet. You'll have what's called a dry coil. And if you're in a place where that's the conditions, then we actually design at 45% relative humidity. And those things do change the load. So we do want to choose the right, both sensible temperature, that temperature that we feel, and the relative humidity that we expect to have our houses at. We need to make sure that we get all of those correct when we're doing our design. Then we move down to system characteristics. If you're in a home that is going to have a furnace installed, you need to click that and then put in what you think the input BTUs for the furnace are going to be. And so once again, this is a little bit like that blower motor heat in that you can put a guesstimate in at first, and then when you're actually have your loads and are looking at furnaces, change it and see if it changes the load enough that you need to make a different equipment choice. But what this is actually about is the ventilation load that ends up being added to the load of the house because there's a combustion appliance, and the combustion appliance needs to use the inside air for the combustion process. So if you're installing a direct vent, um, sealed combustion piece of equipment, and you're actually venting both the intake air and the exhaust air to the outside, then you would not click this. And if you're installing a heat pump, you would not click this. I know that we might have some people on this webinar that are not designing in only California, but for those of us who are designing in California, um, then we should not have humidifiers in our homes. So that should never be clicked when you're designing in California. So I see a question that, what if the furnace is located in the attic? Um, yeah, I wouldn't click it for a furnace that is located in the attic, on the kind of on the caveat of that if the ceiling assembly is really leaky, then I might want to see what the load difference is, um, by clicking that and putting that information in. So if I know that I'm going to get to do an air sealing work scope to the ceiling of the attic, um, then there would not be the additional ventilation load. It should be coming from the vent, either the vented attic, or hopefully you're doing a high efficiency furnace and actually just taking the air directly from the outside. Room vent type. This is for, and this once again is a screen that you might want to change your resolution to 100%. This is for when we're taking outside air and supplying it into the house, into specific rooms. So not into the heating or cooling system, duct system. The room vent type is when we have, say, a supply only fan that we're bringing into specific rooms, so that would be outside air. If we have an HRV or an ERV, we should not have ventilating dehumidifiers in California, but for humid climates, they really need to have ventilating dehumidifiers. So those would be chosen. And so on both the cooling and the heating, it's the same choices. The house that we're going to be doing at first does not have that. It's going to have exhaust only ventilation. So at this point, I'm not going to fill these in, but let me just show you in that if I choose heat recovery, which would be a good balanced ventilation system for homes in California, now we need to tell the software what the recovery efficiency is of that piece of equipment. So I need to go and research my various pieces of equipment and fill in what the actual effective, sensible effective recovery rate is, what the manual J states it as. Very few pieces of equipment actually call it SER, sensible effective recovery. Many of them call it apparent sensible effectiveness. So mostly you're looking for the whatever of the performance recovery factors are, you're looking for the one that is the effective one. And then you need to look and see, well, at what design conditions and at what CFM, what is that percentage of recovery? And so once again, this is a place where they don't give you that many choices. This is lower winter conditions than what Ventura would be subjected to. Uh, and this is one place where I definitely would check the Title 24 documentation for what the Title 24 documentation came up as the CFM. That's going to be the minimum that we're going to put in the house. And if you've already done your design and you know how much it is, then you can use the number, anything that's above the minimum. But if you haven't done that design just yet, then take a look, see what the Title 24 docs came up with to figure out what CFM is probably going to be supplied to the house and choose that recovery efficiency to put into the load calculation. And then you can always go back and change that should, should you find out that you're using a different piece of equipment or you're doing a different airflow rate. And these are just fields that you can just fill in for that. So we're going to go back to none for this house. Click out of that. Central vent type, that's when you're actually ducting into your heating and cooling duct system. And so you get the same choices and you get the same fields that you need to fill in. But with an ERV, not only is there sensible recovery, but there's also latent recovery. And so you would need to look for that uh, in the spec sheet of the ventilation system that's being installed. Overall in California, we should be doing HRVs if we're doing balanced ventilation. That's what those are. Then if you do need to put in that blower power for the load, you're going to look for that in watts off of the spec sheet of the piece of equipment that you're looking at. And then there's the hot water piping, which I don't think many of us are ever going to have to use. Manual J8 has kind of its own ventilation calculation, and they've recently started recognizing that 62.2 has moved on and changed. So there are, in different jurisdictions, so different states basically are on different iterations of the ASHRAE standards at this point. We're on the recent standards. So choose ASHRAE 62.2 2019. The number of bedrooms will get filled in from another screen that we'll be using. If it has a master bedroom, go ahead and check that. And in this situation, the house that we're going to be doing today is exhaust only ventilation, a little bath fan. So I'm going to put that in right now for our load. And that bath fan is actually functioning at, I want to say it was like 40 CFM. So I'm going to put that in. Just kind of a lot of ventilation, continuous ventilation for a little bathroom, but that's what it is. All right. So those are what needs to be filled out in the zone information screen to be setting up our load calculation, to be getting everything correct. So now let's look at this little screen called load calculations. And we've got 4 screens that come up in load calculation. The one that we really need to look at is our infiltration load. So this will come up as a different set of parameters that you can choose if you use either of the other 2 methods that are allowed to be used. In the blower door method, this is the screen that comes up. And the first thing that we need to look at, and so once again, you might want to toggle to a higher screen resolution if you're not there. We've got these 5 different conditions for wind shielding, and they give us nice little descriptions for us to choose. And so this house that we're going to be designing does have it's basically a typical suburban shielding. So substantial number of obstructions, shield most of the perimeter buildings, hedges, solid fences. So that's what we're going to choose for this house. It is a 1-story house. Really, we shouldn't be using manual J for buildings that are taller than 3 stories. So this is a 1-story house. We are going to do a single point blower door test. The test pressure that the load calculation procedure is actually doing all the math on is at 4 pascals, but we don't do a blower door test at 4 pascals. So that's why it defaults to 4 pascals, is because that's what the math is doing. But this software allows us to tell it what pressure we've used, and then the math in the behind the scenes is going to go through all the calculations and take it down to 4 pascals for us. And when we did the blower door test on this house, the CFM50 number was 281. And you'll see that a bunch of math was done already because actually this is what the load calculation procedure is really drilling down to is an equivalent leakage area in square inches. So that's what that leak is. And you'll see that the ventilation that I put in, that exhaust ventilation, has shown up down here on this screen as well. So that's our infiltration screen. I'm going to pull up the load meter just so that you can start to watch it change as we get into actually putting in our different assemblies. But we've got a little bit more setup to do. So now we're going to go back to this grid. And one of the first things that I like to do is to actually just change my scale. So I clicked in the gray corner and it brings up the scale. And I'm going to change it to 1/4 inch per foot. So then I am going to move this out of the way. Maybe move this over a little bit. So over here, when you open a file, you're typically going to come up with just sheet one and the building layer. Now I've already put some other layers in to show so that I can draw the building and do other things for us more easily. But you're going to show up with just sheet one and the building layer. And so basically I right click on the sheet one and I need to edit the sheet. And what's really important about editing the sheet is I need to give it, now it's saying elevation, but that's not really accurate. I need to give it a number other than 0, greater than 0. So since this is a one-story house, I'm going to just give it an elevation of 1. Now, where it becomes really important is if this was a two-story house, it's important that your lower story have a lower number than your upper story. That's how this software figures out how to put the layers, the stories of the building. So if there was a second story, I could put it at 2, I could put it at 9, as long as it's a higher number than what I've put my lowest level of the building. And then if I want to, I can change, the name of this. So you can put whatever and change the name. This is the other thing that's really important is that building level is building level. I don't know what that sentence is supposed to mean, but that needs to be checked. That's how the software knows that what I put on this sheet is what the load calculations need to be happening on. So you need to have that checked and you need to choose an elevation number. So now I have those two things set up. I need to choose my compass direction. So if we draw the house as we saw it in those plans, we know that the front door was down at the bottom of, will be at the bottom of our screen. And so north was actually over here. So I need to change that compass direction. And really important not to forget that because the direction of the house on this site makes a difference as to the load of the building. So we changed that. Another thing that is just going to help us all out is to change. This is your snaps are going to default to 12. I already went in and I had changed it the other day to 3. That's where I like to have it at because it gives me a little bit more degree of accuracy when I'm building buildings because houses aren't built often in completely whole numbers, and they definitely are, 2 foot 4 inches, if you can see that clearly, right? That's, 4 inches is typical. I've got 7 foot 10 inches, 5 foot 5 inches. So, you know, buildings are not made so that they're easy for us to put in this very kind of square software that isn't giving us good definition. And so, although we can take a whole wall and go to the nearest foot, it just I find it easier if I don't have to struggle so much in figuring out how I fit that building into the software when I'm drawing it. And going to one, the software gets really glitchy and just things start moving by themselves. So going to three is about the best resolution that you can do. All right, so let's get on to actually defining our building from our site survey. So I'm just going to actually, I have it here. Let me show it to you. Here's our building assembly details. I wrote them out on the side um, for us. And so let's go in and start defining our building. So this is the Wrightsoft screen. I don't know what the screen is like in other softwares. We've got this radio button screen, and this is our basic description. And then there's a screen that we can do some custom layers if the radio buttons don't define our components as well as we need them to. So we have actually a ceiling under attic. So we've got all these different choices and all these different assemblies that we can use. So you need to choose the right assembly. And we have an asphalt shingle roof and it's dark color. So we definitely need to change color. That's another one that makes a difference in our loads. So we actually need to make that choice. There's no roof insulation. It's a vented attic and it has ceiling insulation of R49. And we don't have an R49 choice. So that means I'm going to have to go into the custom layers. So I can choose the R50 or the R44. I know that I'm going to have to go into my custom layers. And then my ceiling finish is actually 1/2 inch gypsum board. And so those are the only choices I get on this screen. But then when I go into the custom screen for my roof assembly, I've got all the layers. So I've got the outside air film, I've got the asphalt shingle roof. The plywood is actually not an inch, it's actually 1/2 inch. So I'm going to change that, and that changed the R value of that. The attic ventilation has a layer. Then what happens with the insulation is that the software is they're figuring 8-inch joists. And so that does happen to be what I have in this attic. So I don't need to change that, but I would change it if, say, it was 2x6 or potentially 2x4s or 2x10s. I would change the dimension of that. This is what the software is saying fits between the joists is R21, and then the rest of my R49 goes above the joists. And so that's what this is. And so since I chose the R50, I actually need to change this to R28 so that I end up with actually that R49. And then I've got the 1/2 inch gypsum board and I've got my interior air film. And so this is actually the effective R value of this ceiling assembly. And if I remember, I should change the description to match any changes that I made. And so now I have that defined as my ceiling assembly. And I need to do all of this before I ever start drawing on this grid because this is what's going to define everything that I draw on this grid. The floors, we don't have an exterior floor. This is actually slab on grade. So I'll just show you quickly what some of those other ones look like, but this is slab on grade. They expect us to know what the soil type is. And that's one of those things like, I don't know, maybe you know about a particular location, maybe you don't. I don't know. I'm actually guessing for Ventura. I'm going to say light dry. I'm going to say that it's definitely not heavy damp. It might be heavy dry or light damp. I don't really know. There's no edge insulation. There's no slab insulation. There's no edge duct. It is on grade. The house has carpet in like three of the rooms and then vinyl flooring in the other rooms. So I'm going to start out with the carpeted rooms and have it just define that and know that I want to go in and change those other rooms to the vinyl. And sometimes that changes the load and sometimes it doesn't. So the flooring is a little bit of one of those things that you might be clicking some buttons and it might not actually do anything to your load. The glazing, we have NFRC values for our glazing, which makes life really so much better when we're dealing with the windows. So they're dual pane windows, but we've got all these different choices, single, double, triple block, and then skylights. We've got double pane windows. All of them happen to be operable, but in most houses, that's not going to be the case. So you need to choose. If there's more operable than fixed, I would start with operable, and then I'd go in and change the ones that are fixed. They do have this does have clear low E. If you know what gas is in between the panes, whether it's air or argon. Mostly, I've never found good information for me to be able to make an educated choice of the low E coatings. The framing material I can either see on the order sheet or at the house, and these are vinyl. There's no storm pane. And figuring out the glass is actually often difficult. And on a site visit, you can typically see what the gap is between the two panes of glass and choose which is appropriate. And the glass thickness I find very difficult to figure out on site. But because we actually have the NFRC values, I didn't really have to go through any of that. That is for existing homes in particular, where all we can do is basically describe what we're seeing on site and doing the best that we can and seeing that a default number comes up on the side and that's what's going to end up being used. But since we have the NFRC numbers, I can go to this custom value screen, click that it's got NFRC, it's clear low E, make sure that I have the right number of glazings, the frame type is vinyl, they are operable windows, and then I can change this to 0.3 for my U factor, and my solar heat gain coefficient for these windows is actually 0.25. And make sure that you hit tab after you've put in the values, because otherwise they won't stick. And then there will be problems with your load calculation. That would be one of those errors that will then infiltrate throughout your entire load calc. Our wall. Our wall is, pull it up so you guys can see it. We actually have two walls. We have the exterior walls, and then we have this demising or partition wall between the garage and these couple of rooms. So we're going to start out with defining our exterior wall and then know that we have to go in and make changes for that demising wall. So it is a frame wall, but once again, we have all these choices and we even have knee wall. So you need to take note of if there's any knee walls, that's a huge part of your load, and define those properly. This is a frame wall. There are no knee walls in this house. The exterior is wood. It actually does not have sheathing. So no sheathing, that this is an older house. The cavity insulation is actually R10, which once again, I don't have an R10, so I'm going to go with 11. The interior finish is half-inch gypsum board. I need to choose the color again, and the color of this house is light. And so, that's kind of subjective, the color thing. You just have to look at it and decide, well, is it dark? Is it medium? Is it light? Or is it white? Um, there's no exterior board insulation. It is 2x4 framing. It is 16-inch on center. And that's important, the framing factor. And then there's no interior board insulation. So after I've basically defined the wall, now it's come up with U factors for the wall, but now I need to make the few changes that I need to make. So it's the 2x4, but it's not R11, it's actually R10. And there's my effective R value for that wall. And once again, if I remember to, I should change the description. And this is the framing factor right here. So if this was a 24-inch on center, that framing factor would be different. And if you know, then and then you don't see that being right, then get that corrected. All right, so there's that. And then the door is just wood solid core. Okay. So now everything's set up and we have a whole bunch of the actual load calculation stuff going on in the background already in the software. So when I go out to a house, an existing home, I typically will measure it and just put the dimensions on the screen like this is, like I've done here for you all to see. And then because the manual J procedures are to measure the exterior walls, not the interior. And that's a problem with a couple of those softwares that are actually powered by manual J, Amply and Conduit Tech in particular, which actually use the scanning softwares. People are scanning the houses from the inside. And if you do that, you need to do the math to figure out how thick is that wall, and you should be adding that amount, that measurement to what you put in your load calculation, because that's what we're actually measuring is the entire enclosure from the exterior. So here's the exterior measurements. Then I go inside the house and I start doing measurements and now I can start drawing the building. So I wouldn't normally have all these interior measurements, but I have them here for you so that I can get through this fairly quickly. So these are the drawing tools in Wrightsoft. This is the basic room drawing tool. I just clicked on it and now I can make a big rectangle. I'm going to try to do this fairly quickly. For the garage, this right here is edit points. And so that gives me some edit points so that then I can make some corrections since this isn't an exact rectangle. The garage has that little bump out. And so there's the garage and I can type that it's garage in there and see, so we've started to get some loads on our load meter. But the garage is going to be unconditioned. So we're going to end up taking the garage out of the load completely. But we'll leave it in for this moment. So I'm going to get these other rooms drawn in. And this is the dining room slash kitchen. And that one is a nice rectangle. Go up to the living room. And the living room actually has a fireplace. And so you're going to notice that we're giving the fireplace to the living room. And there's choices that we need to make as to some certain spaces, what room the load actually belongs to. So the fireplace opens into only the living room. It doesn't open into the bedroom that's on the other side of it. So we're giving that fireplace to the bedroom. I mean to the living room, not to the bedroom. And this is all just stuff that on the one hand is making things easier, and on the other hand, is just the way this software is. So we get it all drawn in. And I'm not going to lie, the software can be a bit glitchy and a little bit sensitive to not going exactly where you want it to do. So we're going to call that the bath. And this was the living room. And so be noticing the load meter. It is factoring in all of the walls, the exterior walls of these various rooms that I am drawing in. Do this. So as you're building it, you can see the loads changing, and they might help you actually notice if you miss something or if something's off at all. Now, this bedroom has this closet bump right here. So it's just a little closet. So it actually just gets included with the bedroom. There are two closet spaces in this hallway. And so we're not actually we don't need to show those closets per se. As the designers in particular, we just need to know that that's what that space is and that I can't put a grill there per se because it's actually a closet and therefore the air wouldn't end up moving through the space. But the load itself is what I'm concerned about, and I want that load to be part of the hallway's load. So there is a closet right here in the hallway, a little linen closet, and then there's actually a closet over here as well. And so we're almost done drawing this house. We've got just the one last bedroom, and there's these two closets in the bedroom, one on each side of the fireplace. And so those actually are also just going to be part of that bedroom two's load. So now I can get rid of those dimensions and we can take a look. And we can take a look at the load so far. Now I don't have the doors and windows in yet. And I don't have this demising wall defined from between the garage and the bathroom. So I did a right click and that brought up this project sheet. The project sheet is an important part of building your loads. So the first thing is that we can do the ceiling heights. So the garage actually has a 10-foot ceiling height, and that's the room that I'm in right now. So I'm going to change that because of the surface area of the wall that I want next to the house itself. And then the other thing is that if it was anything, it was going to be air only. But in terms of the garage, I don't want it included in the load calculation. It's not going to be conditioned space. And I'm actually not going to have conditioning, so I'm going to change those to none. And here I can go to room type, and there's only the 4 room types: other, kitchen, bedroom, and garage. And I'm going to change that so that the software knows that that's a garage. There shouldn't be any ducts in the garage. So actually, if this was a furnace in that garage, then there might be some ducts in the garage. This is a furnace we're going to end up putting in the attic, so there's not going to be any ducts in the garage. So there shouldn't be any duct load. And I'll show you what to do for the rest of the house, which is what you would do to take the ducts out of the garage if we were doing that. So we're going to do all of that. And you should have noticed that the loads changed when I took the garage out of the house. And now in the project screen, I can click on 2 rooms simultaneously. I'm hitting shift. So I've clicked on the living room and now I'm going to hit shift. So now I have the 2 rooms that have the partition wall. And I can go over, and actually they're 8 foot. So I'm going to change that to 8 foot since I noticed it right now. We're going to cancel that. We're not going to do that screen just yet. This is going to be air only for both heating and cooling condition. There's no hydronic there. And so now I can go into the walls, the ceilings, and the floors for each of the rooms, whether that's individually or if I choose to do rooms, more than one room. But these 2 rooms have that demising wall that I need to define. So they've got their exterior wall, and the second wall type showed up. And let me just show you that on the other rooms, a second wall type. We can put in a second wall type is if there is a second wall type. But as soon as I took the garage out of the load for these 2 rooms, it knows that there should be a second wall type, and it put in a default second wall type. So I need to define this room appropriately. So it's not actually exterior siding, cladding. The inside of the garage is 5/8 gypsum board. And then there's no sheathing. It has no cavity insulation in that wall, even though it should. And then the interior is 1/2 inch gypsum board. And I'm going to put that as white because no matter what the color is, it's the sun's not shining on it. So that's the color of it is basically north and it's white. It's not, it's needs to not be in the load the way that the colors are. It's 2x4 framing, it's 16-inch on center, and there's no interior board insulation. So now I have both of the walls defined, and I'm being asked about the adjacent temperature between the two spaces. Unless I know for sure that the temperatures are going to be something in particular, I'm going to leave adjacent space temperature. It's something that often there's no good way to really know. But if you do know something about the space and or can measure it on a design day, then you can change those. We're going to do a global change by going over here. I right clicked on the building layer, and now I'm going to select rooms. All the rooms are selected, but I don't want the garage selected. So I'm just going to, I hit shift and clicked on the garage. So now just the rooms of the house are selected. So now I'm going to go through and make sure that they're all the same. So I'm having air only in my heating condition and my cooling condition. I'm not going to do room type just yet. All of these happen to be 8-foot ceilings, so that makes that easier. We'll look at internal loads in just a second. Our ducts, though, we need to do our ducts. Our ducts are in this vented attic. Both the supply and the return are in a vented attic. It was asphalt shingle for both. We're going to do a radial design with center of room outlets, and we'll be able to move that around, but it's just a basic description. For California, we're always going to have extreme air sealing for our duct system, and hopefully you're doing R8 ducts, but you'll put in whatever insulation level you know. If you know you're going to get to deep bury the ducts in the attic insulation, this could be all the way up to an R20 or so. With heat pumps, we definitely want our heat discharge temperature at 100 or less. And so if you know what that is, that you can change that. This is something that's fairly new in this software, is that we don't have to only use the manual J8 procedure, which was something that was basically impossible to figure out for yourself. So now we can either do percentage of leakage. And so for California code at this point, it's supposed to be 5% or below. I hope that you're actually doing way better than that. And so if you are a contractor who knows that you do better than that and what percentage your systems typically come in at, you can put that in. I like to insist that people I work with go with a CFM maximum. And so I want to see duct systems that have no more than 20 CFM of leakage, no matter what the size of the system is. So that's something that you have to figure out and know. But what all of this is doing is that it's describing what the calculations need to do to come up with duct loads. And so now each of the rooms are going to have various duct loads once I click out, and we can look at them individually. There's also for your ventilation. Uh, you can go to individual rooms. So see, we've got duct loads now in this room. If we were doing that balanced ventilation system, this is where you would put that. So if I knew that I was putting 15 CFM in this room and 30 in this room and 30 in this room, you do the supply ventilation in the various rooms. And this is where you would add that in your project sheet. And any other changes that you need to make. So if a room had a different ceiling, you'd go to the ceiling for that room. If it has something different on the floor, which I said that a couple of our rooms actually have vinyl. So the hall, the dining room, kitchen, and the bath are all vinyl. So I could choose all of those rooms, and then I can change that flooring to vinyl, and I can glance at the load meter and see if any change was made. And in this situation, it didn't change the loads. So now we have 15 minutes to add our doors and windows. So let's get the doors and windows. Goes under notation. There we go. You definitely need your project sheet for doors and windows. If a garage is not left open all the time, you don't really need to put the doors and windows in an unconditioned garage. You do need to remember to put the man door in between the house and the garage if there is one. So you draw it in, make sure that it's what you expect it to be, the wood solid core. The openings is just for visual. It doesn't matter for the load calculation. But the door itself, this door is actually 2.8. So that's 2.67. And it's 6.8, just 6.67. And a garage door is shaded. There's no question about that. The garage door is shaded. You have to manage to click out of it for it to stick. But be careful about whether you choose shading for doors and particularly for windows. So there's that door. I can do a little trick to hopefully make this go a little bit faster. Here's where the front door is, and that's a 3068. So the only thing I need to change is that this is a 30. And this is not shaded. So we want to get rid of the shading for the front door. So I've got the two doors in. Now I can put in the windows. And so I've got a 3040 down here. And so I happen to have that the 30, the 40, that it calculates the area. Don't put in shaded for most of your windows, even if there's a great big tree out front. It's going to mess up your loads. That exterior shading is only if there truly is like an exterior shade that's coming down over the window that you don't have shading coefficient numbers for. You want the head height, and so these do happen to be 6.67 head height, so that works. Otherwise, you need to change that. Configuration is important. If you have a bay window or a garden window, that changes the loads. And so those are the windows that pop out from the building itself. Uh, but otherwise, you need to put flat, but you do need to make that choice. We've got the NFRC ratings that we put in. We want to put in that there's internal shades. And this is where there's all kinds of shading choices. It's not a huge amount of choices, but you need to put it in. You need to make that choice and figure out what it is. And you need to know what the internal shade fraction is. So I actually wanted to choose the 45. So that's the 45 degree is the angle of the shade, but is the shade pulled all the way down? Or is it only 50%? So how much of the window is it covering and based on how it's closed? And so you kind of have to make judgments on that. And you also need to think about, even though when you're there, the shade or drape or whatever it is may be wide open, if you're not there on a design day, you need to either ask or think, so on a design day, this is a west-facing window at that hottest part of the day, are they going to choose to actually shade the window more than what you're seeing at the time? And so that's what you should be putting in right now for your load calculation, is how that shade would be during that hot day in July. The insect screen, there's going to be an outdoor insect screen, and this type of window is going to actually have a 100% coverage of the insect screen. Sliders are typically 50%. Casements are going to be 100%. You kind of get to know windows and whether a screen, if you're not actually seeing it, what percentage of the window that's going to cover. And then we've got our horizontal projection and our vertical separation. So I've got a 1'6" on this side of the house. So 1'6". So that's 1.5. And then I've got a 1 foot overhang. And this is really tedious. Putting windows in is incredibly tedious because there's so many of these things that you have to fill in on every single screen. But there's a few tricks, thank goodness, in the software so that I can grab a copy of that window, move it over here. Most of the things are the same, right? The overhang's the same, the vertical separation, the exterior bug screen are all the same, but this is a 3030. So I definitely need to go in and change that to 30. And the software decided to give me a 2 foot 11-inch window instead of my 30 window. So I need to take note of that and change that. I have another 3030 down here, so I can try to grab this window. And like I said, the software can be glitchy. So even though this is supposed to be making an absolute copy of that window, we'll see. It gave me one. So it changed, it decided to change it again. So I needed to take a look and change that, but everything else is the same. Here's the 3040. I can choose whatever window I want. I'm also going to do copy and paste and just grab that window this way and change this to a 3040. Right? But everything else is the same for those windows. We've got another 3040 on this side. But this 3040 doesn't have the overhang. So I need to get rid of that. There's actually no overhang. So there's no vertical separation. And otherwise, we've got all of that going. And then this is the same window right up here. So I can copy that window. Put that in this bedroom. And that one's the same. And then I've got we've got a window and a sliding glass door over here. So I've got another 3040. And it doesn't matter that it's like exactly at the right place on the wall. It needs to be in the right room on the right direction, the right compass direction of the wall. It doesn't have to be in the exact place of that it is actually in the room itself. So we've got the 3040, and this one we have the 6.8. We've got a 12-foot overhang and a 1.33 vertical separation. So we've got a 6.8, 6.67 overhang and 1.33 for that. And then we've got a sliding glass door. And we could go in and change it to a sliding glass door, but that's 100% visual. So this is a 6.0 and 6.8. And it had that same overhang, and it's only going to have a 50% bug screen. Sliding glass doors don't have 100% bug screens. So that one's going to be a 50% bug screen. So there is our house, and there is our loads right there. I want to show you what is really going on in the background is this worksheet. This is actually what's going on, is that all of these assemblies we defined in that construction bar. And this is what the old timers would say when they do a spreadsheet. This is what's going on, is that the software is looking up all of these different assemblies and putting the construction numbers and the U factors based on the construction assembly that you described, as well as the direction of the wall. So you gave it the compass directions, and it's going to the tables that are in the load calculation manual and pulling all of that out based on what you defined. Now, you don't ever want to change anything in this screen because you'll unpin it from your drawing screen. So it's an either or choice. If there's anything that you want to change in this screen, know that anything you do in the drawing screen is not going to go onto this screen. But this screen, so there's the poll up that hopefully you are all seeing, so you can fill that out. And I'm guessing that I can probably close it off of my screen while you guys work on it. This is giving you just all the final numbers and loads for the different rooms. So it's informational. We can go back in and we can decide on some internal gains if we want to. So, on that hot August day, that hot July day, is there going to be some internal load in the kitchen? Is there really, is the oven really going to be um, on? Is the range hood with the vented hood, is that actually going to be on? There's some scenarios that they give you, or you can do custom choices if you want. Is there going to be somebody in the kitchen? Is there going to be one occupant cooking in the kitchen on that day, or are we making tuna salad? So, there nothing's going on except maybe a person. Plants have load. If it's really a lot of plants, you can add the plants. Uh, I typically don't, I very rarely will do internal gains. They um they just end up inflating the load tremendously. But you're supposed to, just not be extreme about it, think about it and make those choices. But that is what happens. This is a helpful screen as well. And there's a report that you can print of this, which shows you what the loads on the different parts of the house are and gives you a sense of, well, gosh, if we could decrease in infiltration, then that could help us bring our loads down. But that is how you would apply your knowledge of the procedures to the load calculation software. Um, And we're going to go to the closing slides in just a second, but we'll take a look. This got filled in. Oh, and this is one thing I wanted to show you for the bedrooms, where those various places where I said that the bedrooms will get filled in for some things like the ASHRAE calcs. You go in and you just tell the property sheet what rooms are bedrooms. This was the kitchen, so you can tell that. Nothing really ever happens with the kitchen, but then the various things get filled in, right? So now there's two bedrooms that'll show up on that report. And in the zone information, there's two bedrooms for the ASHRAE number. And that is that. So let's go back to Chloe wrapping it up.
Thank you, Judy. Thanks for that marathon and deep dive into Wrightsoft. And as I mentioned all at the beginning, this is a little bit different than our normal training, and we would love to hear from you guys what your thoughts are. Do you want to see something like this again next year? Do you maybe want an opportunity to ask Judy some in-depth questions on this material in less of a structured format? Anything you can think of, let us know in the poll, and I will stick around for as long as it takes for everyone to provide their feedback. So when we finish the webinar, you guys are welcome to hop off if you're ready. But if you're still filling out that poll, I will hang out for as long as it takes. Um, if you are looking to get AIA or ICC LUs for this event, those should be automatically distributed, but if for whatever reason you're not seeing that reflected in your portal, just reach out to me at this email address here. You are going to be getting an email with the slides from today, and the recording will get posted to our on-demand website soon. We've also got some exciting courses coming up, not as many as usual because we are reaching the end of the year, but it's also a great opportunity to give your thoughts on what you'd like to see next year in our 2026 calendar. So again, if you haven't yet, please take a moment to fill out that survey and let us know what you want to see next year. And I think that is it from me. Thank you all so much for being here. And if you have any questions for Judy, I guess we're right at time here. If anyone's got any pressing questions, I think we could probably stick around for more minutes.
Yep,
Okay,
absolutely.
great. And if there's no questions or nothing coming to mind right now, you can always reach out to us later. Um, and if not, thanks for coming in today, guys.
Yeah, we could potentially do slightly longer if people want, or there's a lot of information.
Yeah, absolutely. There's a lot of flexibility we have with these trainings. So if there's anything that you thought was missing today or that you really, really liked, that's all great feedback for us in the survey. All right, Judy, I am gonna hang out just until everyone clears out, just in case anyone's still filling out that survey, but I don't think we have any questions, so you are welcome to hop off as well.
All right. Thanks, Chloe. Good
Thanks
seeing.
so much, Judy.
All right. Have a good one.